Okay, so the third question we're going to cover for the preparation for the quiz number 2 is going to be for the punch and the die sizes, and that's what we have in the sheet metal working. So what we're going to start with is have a look at the equations, and the first thing we need to calculate is going to be the clearance. The clearance can be calculated by using the equation 21. The clearance is equal to the AC multiplied by the T. We have to remember something. The thicker the metal is, the higher the clearance required is. We can see that. The thicker, that's the clearance we're talking about. The clearance is going to be the distance from here to here. The punch should be smaller than the die by a certain clearance to allow the materials to flow through. So this is clearance here. The higher the thickness of the metal is, the higher the clearance required. So that's what we can see in the equation 21. The clearance is equal to the AC, which is clearance allowance, multiplied by the T, which is the thickness of the stock. Now the value for the AC is going to be given by the table 21. Depending on the material we're going to have, for example, the aluminum alloys at all timbers is going to have the value of 0.045. If I'm going to go for the harder aluminum, okay, soft cold rolled steel or stainless steel, which is harder than the aluminum at the bigger or the timbers, we can simply have the value to be 0.06. Now for the cold rolled steel, half hard, stainless steel, half hard and full hard. So maybe I need to make this one larger for you. Okay, then the value of the AC or the clearance is going to be increased to 0.075. Now it's going to be nice to write down the equation on your paper. The C is equal to the AC multiplied by the T. So now simply we can try to do a basic calculation for one of the example that we are going to create right now. Let's say that my thickness of the plate is going to be about 11.5 millimeters. Sorry, and is made of stainless steel. So go to the stainless steel here. Here's the stainless steel. That's the soft one, or the hard one. Let's try the hard one. So the value is going to be 0.075. So this will be multiplied by 0.075. So the clearance value is going to be 0.86. The clearance value is going to be 0.86, sorry. Okay, so that's how we calculate the value. Now, what about the diameter? What about the punch diameter we're going to have here? So the punch diameter is going to be equal to the bulk diameter minus 2c. The bulk diameter minus 1c, 2c. So let's say that the diameter here is let's say 2.5 centimeters or 25 millimeters. So I'll multiply that by 2 equal to, and give it negative, and plus 25. So the punch should have a diameter of 23.75. The blanking die diameter is going to be equal to the blank diameter. So the diameter here is going to be the same diameter we have for the blank itself. That's for the die. Now for the punch and die sizes, for the round hole or diameter of DH are going to be determined as the hole punch diameter is the DH, and the hole die diameter is going to be DH plus 2C. So you can see in the blanking, we need to have the exact diameter of the blank. And the punching, we need to have the exact diameter of the hole. So that's how it's worked between the blanking and the hole punching. So in order for the slug or the plank to drop throughout the die opening must have an angular clearance, and that's what you can see in the figure 27, or 25 degree or 1.5 degree on each side. I hope that the diagram is here. Yeah. So you can see that once again, these are the clearances, C and C. This is the blank pieces. Diameter of the blank pieces is going to be decided, and then the punch should be smaller. In the case of the hole, the punch diameter is going to be equal to the diameter of the hole, and the hole, the die opening is going to be plus the 2c. We need to have this angle to provide an escape. We don't want to have the friction to go all over the cross section of the cylinder. Now let's go back to the equation we have here. The force is going to be equal to the shear strength of the sheet metal, which is a property of the material, multiplied by the thickness of the stock, multiplied by the length of the cut edge in millimeters. In a blanking, punching, slotting, and similar operation, the L is going to be a perimeter length of the blank hole being cut. So it's going to be square shape. It's going to be the height plus the length multiplied by 2. It's going to be a circular. It's going to be 2 pi r. Okay, that's how we can get the parameter of the cut. Now, the equation also can be calculated. Alternative way of estimating the cutting force, use the tensile strength. It's going to be 0.75 multiplied by tensile strength, or the ultimate tensile strength of the material, multiplied by the thickness, multiplied by the parameter. Now let's have one example on that. We have a round disc. Again, to hide that, we have a round disc of 150 millimeter diameter. Is to be blanked, not not punched, from a strip of 3.2 millimeter half hard cold rolled steel, whose shear strength is going to be 310 megapascal, and that is given as the TS value. Determine the appropriate punch and the die diameter, and B, the blanking force. So without looking there, I only going to start to do the calculation here. So the first thing I'm going to calculate is going to be the C. So I need the thickness 3.2 multiplied by the value for the AC, which is given here 0.07 times 0.075. So the clearance value is going to be 0.24. Now we need to make the diameter of 150. That's the diameter of the blank. So diameter of the punch is going to be 150 minus 2c. So I'll multiply that by 2, give it a minus, then plus 150 millimeters. So it's going to be 149.5. Let's check that. That's correct. And okay, so that's the punch diameter, and this is the die opening diameter. Now let's continue with calculating the forces. First, we know it's 155 millimeter diameter. So I'm going to calculate the parameter in millimeters. So we're going to have 150. That's the D multiplied by the pi. So the L is 471. This will be times the 3.2. Okay, and then I get to multiply it by the 0.7. And multiply it by the shear strength of 310. So the value should be 327,000 or 327 kilonewton. So we calculate the parameter and the force. Oh, wait a second. I choose this one, the 0.71. Okay, wait a second, we should choose this equation. So again, to divide it by the 0.71, so to get this one, divided by 0.7, yeah, we got the number of 467. Okay, so that's how to apply these equations, and I think that we're going to have similar questions. You're either going to be asked to calculate the diameters, or you're either going to ask to calculate the force. Okay, so we can have two questions out of that. Again, you can put these equations in a calculator, Excel calculator, and then by changing the parameters, you can have the answer directly. Okay, so we will go now with another question.